Hey guys! I couldn't sleep last night thinking about how to explain this incredible quantum breakthrough to you. We're about to dive into a world where light particles might just be the key to unlocking computational power beyond our wildest dreams. Strap in, because this is gonna blow your mind. Okay, so let's start with the basics. Quantum computing, it's like, imagine if your computer could think in multiple dimensions at once. Pretty cool, right? But here's the thing. For years, we've been trying to prove that these quantum machines can actually outperform our best classical supercomputers. Now, a while back, Google made a big splash with their Sycamore processor. It was using these things called superconducting qubits, and it solved a problem faster than any classical computer could. But wait, there's more. A team of scientists in China just took a completely different approach, and it's mind-blowing. Let there be quantum light. Instead of using superconducting circuits like Google did, these scientists decided to use light. Yep, you heard that right. Light! They're using something called Gaussian Boson sampling, or GBS. Now, I know that sounds complicated, but stick with me here. In this quantum computing process, photons, particles of light, instead of electronic bits to perform calculations by sending squeezed light states through a complex network of beam splitters and phase shifters where they interfere quantum mechanically. The computing leverages the superposition and entanglement of photons to perform Gaussian Boson sampling, GBS, a mathematical problem that is exponentially hard for classical supercomputers to simulate. GBS is based on optics, meaning it only requires light sources, beam splitters, phase shifters, and photon detectors, without the need for traditional quantum gates like in superconducting qubit systems. Now, let me introduce you to Jiuzhang. No, it's not a new type of Chinese food. It's the name of this incredible photonic quantum processor. The team in China built this amazing machine that can control 50 different light beams at once. It's sending them through 300 beam splitters and 75 mirrors. That's a lot of moving parts. But here's the kicker. Jiuzhang managed to do a calculation that would take our best supercomputers about 600 million years. And it did it in just a few minutes. This is huge, guys. It's not just about solving one specific problem faster. It's proof that this whole approach to quantum computing really works. So, what does all this mean for us? Well, we're standing at the edge of a new frontier in computing. This breakthrough with Jiuzhang and Gaussian Boson sampling isn't just a cool science experiment. It could lead to huge advances in things like drug discovery, financial modeling, and even climate prediction. We're not quite there yet, but we're closer than ever to harnessing the true power of quantum computing. And that, my friends, is pretty darn exciting. As always, stay curious, and I'll see you next time.